Okay, so in this video, you're going to learn about theoretical and percent yield. Now, most of this video is going to be a review of what you already know, but in the last slide, I'm going to show you how what you already know will allow you to calculate percent yield. So first, a review. Mole ratio. Basically, the mole ratio tells us that the coefficients in a balanced equation can be represented as moles. This allows you to convert moles of one substance into moles of another. So, for example, in the following equation, where 2 moles of A react with 3 moles of B to yield 4 moles of C and 5 moles of D, you should be able, if given the number of moles of any of these reactants or products, be able to calculate the number of moles of any of the other reactants or products. Now, while you may be asked to do that on a quiz, this is not how things work in the lab because we can't measure moles. But the mole ratio also allows you to calculate the amount in grams or liters of any reactant or product if you're given the amount in grams or liters of any other reactant or product. So how do we do this? Well, this diagram should look pretty familiar. So let's pretend for a moment that you're given mass in grams of reactant A, and you're asked to calculate the volume of product D in liters. Well, how do you do it? You simply convert grams of A into moles of A using the molar mass. And once you have moles of A, you can use the mole ratio to figure out moles of D. Then you can calculate volume of D from moles of D simply using that magical number 22.4. So this should all be review at this point. Okay, we also learned about limiting reagent, and that is the reactant that runs out first in a chemical reaction. So again, imagine our equation A plus B gives C plus D, and let's say you're given grams of A and you're given grams of B. Well, they can't both be used up completely. In the real world, when you mix these two together, one of them will be in excess and the other will be limiting. So how do you figure out which one is limiting? Well, if given the amount of one reactant, you simply calculate the amount you would need of the second reactant. This is exactly what we talked about using mole ratio, so this should be familiar. Now, which one do you start with? Well, that doesn't matter. So let's say that I decide to start with grams of A. I can then calculate how many grams of B I would need, and then I can compare this to what I've been given. If you have less than you need of the second reactant, well, then it's limiting. But if you have more than you need of the second reactant, it's not limiting. And by default, that would mean that A was limiting. Now, could I have done this the other way around? Absolutely. I could have started with grams of B, and I could have used that to calculate what I needed of A, and I could have made similar comparisons, and I would have arrived at the same conclusion. So again, this should be review. One more review, which is theoretical yield. Now, we may have not called it theoretical yield, but you know how to do this. This is just the amount, mass, or volume of a product that can be formed in a chemical reaction. So again, same exact calculation using what we know about mole ratios to turn a piece of information that we have about a reactant or product into whatever we need to know about any other reactant or product. The important thing to remember here is that it's based on the limiting reagent. So, if we go back to our example one more time, and you're given grams of A, and you're given grams of B, and you determine that A is the limiting reagent, well, then you need to forget about that other number that was given, and you need to go on to do your calculations with grams of A and determine your theoretical yield. So that's what theoretical yield is. Now, here's the only thing that's new. Percent yield. It basically expresses the effectiveness of a synthetic procedure. So while we've been doing all these calculations on paper, in the real world it happens a little differently. And the actual yield is usually less than the theoretical yield. Now, sometimes it's more, but for the most part it is less. So why is that? Well, labs have plenty of errors involved in them, and there are also unintended side reactions going on that you can't control. So how do you calculate percent yield? Well, it's basically just the actual yield that you get in the laboratory divided by the theoretical yield that you calculated on paper times 100. So let's look at a quick example. If you were given the reaction that 2 moles of calcium react with 1 mole of oxygen to yield 2 moles of calcium oxide. Now I'm not going to go through all of the calculations leading up to this point. That's what the review is for. But you should be able, if you were given the mass of calcium and the mass of oxygen, to figure out which one is limiting. And let's say you have determined that calcium is your limiting reagent. Well, then, using grams of calcium, you can determine the theoretical yield of calcium oxide. And in this example, we're going to say that you've calculated the theoretical yield of calcium oxide to be 12 grams. Okay, well that's all well and fine on paper, but now you actually carry out this reaction in the lab and you isolate 9.5 grams of calcium oxide. Not quite what you expected. So, what's the percent yield? Well, you simply plug in your actual yield, which was 9.5 grams, divided by your theoretical yield, which was 12 grams, times 100, and you arrive at the conclusion that you have a 79.2% yield in this experiment. It's that simple. And that is the video on percent yield.